Hello again. This is Math 2232 coming to you from the College of DuPage, and the title of this lecture is Final Exam Topical Outline Fall 22. As always, please be attentive listeners while watching this video. The exam is comprised of 15 equally weighted numbered problems, some of which will have multiple parts. 12 will be part of the proctored VCM test. That will be, again, proctored, and there will be 110 minutes standard time. I encourage you to take this in the brick and mortar testing centers if at all possible, because that is easiest for you and for me. But for those of you unable to do that, there will be provision for you to schedule something in the virtual testing center, but again, that's much less convenient and somewhat challenging. So the 12 problems that will be part of the VCM proctor test include these topics: interval and radius of convergence for power series, Taylor series first 5 non-zero terms, power series for rational functions, term by term differentiation and integration of known series, telescoping series, geometric series, parametric derivatives, and conic sections. Then from the first part of the course, there will be a problem dealing with integration by parts, trigonometric integrals. There will be problems dealing with volumes of revolution, and problems dealing with area between curves. Plus, there will be 3 take-home problems. Now, these are part of the examination and count the same as the problems in class, but they must be submitted to Blackboard on time and are not extra credit. You see, if you skip these, let's say you skipped all 3, you would be starting with 3 problems completely wrong on the final exam. 2 of these are engineering word problems, and 1 is a numerical integration problem. The first one, called number 1 from the take-home, is consider the definite integral, the integral from 5 to 6 of sine x over x dx. Now this is an important integral in applied math, but it turns out that you cannot compute this exactly, so you have to estimate the integral using approximations. So I'm asking you to estimate the integral, this one, accurate to 6 decimal places using the trapezoidal rule. And the question here is what value of n is required to do this estimate to 6 decimal places. Part B, we're to estimate the integral accurate to 6 decimal places using Simpson's rule, but the question is what value of n is required. And then in Part C, you're supposed to perform both of these approximations, showing your work in an Excel spreadsheet format or equivalent format. And then there are some grace notes that I'm providing that may help you. The first grace note, I compute the second derivative of the integrand here, and I show you a graph of it. The second grace note, I compute the fourth derivative of the integrand and show you a graph of it. These should be useful in working the problem. Number 2, a tank of water is 15 feet long and has a cross-section in the shape of an equilateral triangle with sides 2 feet long, with the point of the triangle pointing directly down. You have to draw a picture of this in order to figure out the problem. The tank is filled with water to a depth of 9 inches. Units matter, don't they? Determine the amount of work needed to pump all of the water to the top of the tank. Assume that the weight of the water is 62 pounds per cubic foot. And so what you do is provide your final answer to the nearest foot-pound. And number 3, find the hydrostatic force on this plate submerged in water, and you can see the picture here. The plate is the top half of a diamond formed from a square whose sides have a length of 2. Consider the top of the blue box to be the surface of the water. Find your answer accurate to the nearest Newton. Note, the lengths in the figures are in meters. use the mass density of water to be 1,000 kilograms per cubic meter, and the acceleration due to gravity is to be taken to be 9.81 meters per second squared. In closing, now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now more than ever, take care of yourself because self-care is important, and of each other because we're all in this together. God bless you all, and look forward to seeing you in class.